Welcome to the full solution to the practice questions from lesson 14, lines in 3 dimensions. For our first question, we want to determine a possible vector, parametric, and Cartesian equation for a line, and that should totally say line, passing through points A and B. To find an equation for a line, we need a point and we need a direction. To get a direction vector here, we can use either vector AB or BA. It doesn't really make a difference. To find vector AB, we are going to choose the coordinates of B. So those are 5, -1, and 3, and subtract them from coordinates of A, which are 0, 1, and -1. When we do this, we get 5, -1 minus 1 is -2, and 3 minus -1 is same as 3 plus 1, which is 4. Once we have the equation, and then all we have to do is, and we have a point, all we have to do is put it into an equation. So for vector form, we're going to use either point A or B. It doesn't really make a difference. We'll choose point A in this one. So we'll have 0, 1, and -1 plus some parameter t multiplied by the direction vector, which is 5, -2, and 4. Once we have the vector equation for the parametric, we are going to break it down into its x, y, and z components. So we got x, y, and z components. For x, we are going to have 0 plus t times 5, that is 5t. For y, we are going to have 1 plus t times -2, which is -2t. And for z, we are going to have -1 plus t times 4, which is 4t. And once we have our parametric, we can move on to Cartesian. For our Cartesian, we are going to have, the format is x minus one of the points over our direction vector there. So x minus 0 over the direction vector. In the x direction, that's 5. This is 0. Is going to equal to y minus the point here, which is 1, divided by the direction vector in that direction. That's -2. And that's going to equal to z minus -1 divided by 4. So that is z minus -1 divided by 4. I'm going to simplify this because this is just in bad form right now. We got x over 5, x minus 0 is just 0, is equal to, we don't like the -2 in the denominator, so we're going to bring it up here and multiply it by y to get -y, and -1 times -1, which is +1. So this becomes 1 minus y over 2. And that is going to equal to z minus -1, which is same as z plus 1 divided by 4. So I will have my vector, my parametric, and my Cartesian form here. Cartesian forms here. This is it. This is one here, and this one over here. Okay, we got a big question over here. We got a drone that has a starting position at A and moves at a constant velocity in a straight line. 8 minutes later, it is at B, and here's the coordinates of point B, and we want to determine the displacement, the speed, and the equation of the line, plus how long from position A before it reaches the ground at z is equal to 0. Okay, for part A, we want to find the displacement. I'll do that to decide here. The displacement is from point A to B, so that's going to equal to its position at B minus the position at A, or we can write this as vector AB. Vector AB will be, to find vector AB, we are going to take the coordinates of point B, so those are negative 40, 20, and 20, and subtract them by the coordinates of point A, so those are 10, negative 5, and 100. And this will give us negative 50, 25, and negative 80 as our displacement, and this is in meters. For part B of the question, it's asking us to find the speed, and there's two different ways of doing this. We can find the distance first and then divide it by time by taking the magnitude of the displacement and then dividing it by time, or we can find the velocity first and then use that to find the speed. I'm going to use the latter method just because later on we need to find the equation of the line and we need the velocity for that anyways. So for part B here, we are going to start off by finding the velocity, and the velocity is equal to the displacement over the time that's taken, or I'm going to write it as delta t, and that's going to equal to, we know the displacement, we found it to be vector AB over the time. So I'm going to write this as 1 over 8. The time here is 8 minutes as stated right here. And the vector AB is a negative 50, 25, and negative 80. I'm going to multiply everything in here, and usually I like to write things vertically, but just I'm trying to fit as much as I can in this screen, so I'm going to do it all in here. Negative 50 over 8, that simplifies to negative 25 over 4. And then 25 over 8, that can't be really simplified. I'm going to keep it like this. And then negative 80 over 8 is going to equal to negative 10. And that's going to be the velocity of my object or the drone here. So the speed is going to equal to the magnitude of the velocity, and that means it is the square root of the x component squared, so that's 25 over 4 squared, plus the y component squared, that's 25 over 8 squared, plus the z component squared, which is negative 10 squared. And now I will get my speed as approximately 12.2 meters per second. I'm going to highlight my answer for the last two questions. Okay, good. Now I have this, and for the third part, we're asked to find the equation of the line. So to find the equation of the line, we can use either point A or B. It doesn't really make a difference. We can use either one. I am going to use point A for a good reason, because later on it asks how long from position A before it reaches the ground, and since we want it from position A, it is nice to write the equation from the starting position of point A. So our equation in vector form is going to be our initial position vector, which is 10, negative 5, and 100, plus our t, the time it takes, multiplied by our velocity. And we've calculated our velocity right here, so that's what I'm going to use. Negative 25 over 4, 25 over 8, and negative 10. And the unit for this is in meters. For the last part, we are asked how long from position A before it reaches the ground, and by ground A means when the Z value is equal to 0. Well, that's not too hard because we already have our equation from starting position A. All we have to do is use the Z coordinates to figure this answer out. So for part D, the Z coordinate is equal to 100 plus, so that's coming from here, 100 plus t times negative 10, which is negative 10t. So I'll write that here, negative 10t, which is same as 100 minus 10t. We know that the z value is 0, so we're going to see 0 is equal to 100 minus 10t, and we're going to solve for t by subtracting 100 from both sides. We're going to get negative 10t is equal to negative 100. We're going to divide both sides by negative 10, and we will get t is equal to 10. And we know that our units are in meters per minute in this case, so this will be 10 minutes. If we were asked to find the final position, then we would actually plug the 10 minutes back into the t here, and we would figure out what our final position would be. But in this case, it's just asking for the time it takes, and that's 10 minutes. I hope that this video was helpful in giving you some practice with 3D lines and their applications as well in a velocity and displacement situation. Thank you for watching.